Okay, so first thing I want to talk about is just derivatives of more complicated functions, we call it that. Advanced functions, maybe. And let's work through a few examples. So h of x is, let's call this one 2x squared minus 3x plus 1 divided by x. Okay, so we have not developed any quotient rule, any division rules yet. So we can't do a derivative that involves a division. We have no rule for that. So we actually will have to divide this first. We need to rewrite or redefine the function to do this work. So we need to rewrite the function. We have to eliminate that division. So what can I do with this? Well, I don't think it factors, but the key to this one is this x is a common denominator, right? It's divided by everything. So in fact, we can split this up into 3 separate fractions. Right? It's a common denominator. So h of x, we could write this as 2x squared over x minus 3x over x plus 1 over x. Now, can I now simplify these so I can eliminate that division, those fractions? So what's this first one going to be? What's 2x squared divided over x? Just 2x. Minus, what's 3x over x? 3. And how should I write 1 over x? So I can't have x on the bottom, can I? I can write that as x negative 1. Right, this is h of x. This is the same function, it's just written in a different form, but this form we can find the derivative of. So now let's find the derivative. So let's see, it's 2 is a constant. The derivative of x is what? One x to 0 minus the derivative of 3, it's a constant 0, plus the derivative of x to negative 1. Negative 1 times x to the negative second. Okay, so there's the derivative, but that's in a very unsimplified form. We won't want to leave it like that. It's very awkward to look at that. So let's start cleaning this up a little bit. So what's 2 times x to the 0? Just 2, right? And then how should I rewrite this? That's 0. Actually, so what's x? Well, negative 1 times x to negative second equal to? Minus 1 over x squared, right. And that's even better. But in fact, we often don't like to leave it like this, although it depends on the problem. But we have only, this one is a fraction, this one's not. So we usually like to get this as a single fraction. So I need a common denominator, which would be x squared. I'm going to take this to 2 times x squared over x squared. Get that denominator right. So the answer would be And there it is. So again, on a problem like this, we have no division. So I had to take and divide each by the common denominator, get three separate fractions, simplify those, and then find the derivative of those. Okay, questions on that? So this one, just like the last one with the division, we have no rules for multiplication. So what do I have to do first before I can work this? Yeah, I have to rewrite again, and we're going to distribute this through. So y equals, well, if we distribute 3x times 6x is 18x squared, minus 3x times 5x squared would be 15x cubed. And now I can just use my power rule to find this. So d derivative, or dy dx, 18 times, what's the derivative of x squared? 2x first, minus 15 times, what's the derivative of x cubed? So, see, 18 times 2x would be 36x minus 15 times 3. And I'm done. So, the question may come up, do I need to factor anything out? I can, right? But do I need to? And I don't, because we only factor if it helps us to simplify. And there's nothing gained by factoring in this. It's not a simple answer. It only would be a benefit if I could divide something on the bottom. I cannot. So we'll leave the answer like this. Okay? So there's that type. Second type of question is finding equations of tangent lines. We did this a little bit with the old rule. Now we're going to use the new tools we have. So, let's say that we're given the function that y equals x cubed plus x. I'm going to find the equation of the tangent line at the point -1, -2. And you know, write the answer in slope-intercept form. Okay, so to find the equation of the tangent line, what do I need to have? What do I need to have to find the equation of the tangent line? I have the point, right? And I need the slope, right? And to find slope, I need to find the derivative, right? Because the derivative gives me the slope. So, we first find the derivative. So, m equals the derivative, right, at -1. Can use this notation, not exactly correct, but it'll work. What's my derivative of y? 3x squared plus the derivative of x is 1. That means that at -1, the slope would be, right, so -1 squared would be 1, times 3 would be 3, plus 1 would be 4. So that means that the tangent line we have y equals 4x plus b. And now it's just how to find b, right? How do I find b? Negative 2 is 4 times negative 1 plus b. B must be 4x plus 2. There's the equation of the tangent line. So again, another application derivatives and really a pretty quick and easy way to find those. Okay, the last type of question is finding points where the tangent line is horizontal. Okay, so we're finding those. Okay, so I guess the first thing is where are if it's a horizontal tangent line, what's that mean? What would that mean for a tangent line to be horizontal? If I have some, right, if I got some graph, where's the horizontal line, where's the tangent line horizontal at? Right, in fact, it would be right here, right? So what do we know about this line? We know about horizontal lines on a graph. Something very important about them. And that is, what is their slope? If it's a horizontal line, what's the slope of a horizontal line? It's 0, right. So anytime you have a horizontal line, its slope must be 0. So since the derivative, right, is equal to the slope, that means to find out where these occur at, all we have to do is take the derivative, set it equal to 0, and then solve for x. Okay, very important because there's a lot of important things we can find in those locations. Let's do a problem. Let's say that, for example, I want to find the points where f of x has a horizontal tangent line. And my function is going to be f of x, f of x is x cubed plus x. So what's going to be my first step? Yeah, I gotta find the derivative, right? I gotta find f prime of x. What will that equal? And that's right. And this one's not gonna be very interesting. So what do we do next? That means that 3x squared equals -1. Divide by 3. X squared is -1/3. And then what? And what do you conclude? Yes, there are no real solutions to this, right? So no horizontal tangent lines. That wasn't real interesting. Let's try another one. I mean, that's a fact, and that's something about the graph. But we can look at that in just a little bit. Let's try another one. Maybe this one will have them. So C is going to be f of x, f of x equals x squared minus 2. Okay. So the derivative would be just 2x, right? Because the derivative of x squared is 2x. We set that equal to 0. So x would be 0, right? Now, let's say the question though wanted the point that happens at. How do I find the y value for the point? Y would be, and what I plug 0 into? To the function, right? Y would be f of 0. So that would be 0 squared minus 2, which would be, so is that 0 negative 2? Now, what really is significant about this point on this graph? So there's something very significant about that. What does this graph look like? It's a parabola that's moved down to, right? So in fact, if I were to sketch this out, we would have a parabola like this. I said that, really right here, I have a horizontal tangent line, which I do, right? If you think about it, this for me, here's my tangent line. But what's significant about the graph at that tangent line? That is the vertex, right? And for the whole graph, that is the minimum. We'll eventually get to this, but the horizontal tangent line, since that's where the graphs change from decreasing, or increasing, decreasing, that's going to be where we find these min or max values, right? And that's going to allow us to actually find those exactly. So it's a very, very important thing. We won't get to that until we get a little more experience with derivatives, but